Oh, I am so excited. We're gonna make a cool part right now. It's gonna solve problems. It's gonna raise efficiency and productivity, and it's for my kids. What?
It's about to get crazy. It's about to go down. It's about to go down.
What's up, everybody? This is Titans of CNC. It's Saturday. I just ran right down my street to my shop. I'm alone. Hello? So eerie, it's kind of crazy, but I'm excited because today I'm just gonna go make a part right now, and it's gonna solve some problems. It's gonna be awesome, and then from here on out, it's gonna allow myself and my kids to mill all kinds of cool parts at our house. Boom, in lockdown. We're gonna be milling at my house. It's gonna be insane, right? So let me give you a little breakdown. All right. A few weeks ago, before my kids got kicked out of school, I came up with an idea to make a MakerSpace in my house. I got a little mill, the XS Router from Tormac. It's a cool little mill. You program, you put it, it's X, Y, and Z, boom, 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 boom. It is absolutely awesome. And it's like under $3,000. You can put it in your house and your kids can learn how to actually machine. But as soon as I put the mill in and I started writing programs and I started looking at the table and how the clamps worked, I immediately saw that we were limited. And because I'm a manufacturer who has solved many different problems and who specializes in building fixtures and creative work holding solutions, I thought, you know what? I'm actually gonna take this table out. I'm gonna go to the shop and actually build a custom fixture plate that we can then put in and then put all kinds of crazy Miteebite-Bite clamps and different clamps on there to hold multiple pieces, and it's gonna be amazing. Before we machine the plate right now, I just wanna say, MakerSpace 77, it is a YouTube channel that I just created, right? Why do I need a different YouTube? Because this one is dedicated to parents, to people, to inspire our kids so we can have an army of little makers. It's gonna be awesome. So please subscribe to MakerSpace 77. And through that channel, we will inspire kids to rise up to become makers. And more importantly, we'll inspire parents to actually create these spaces in their houses and give their kids true education. You want to bring manufacturing to the world? You want to change your country? You want to change your state? You need to get these kids now when they're young and teach them real manufacturing. Subscribe to MakerSpace 77 and spread that word, and let's build some crazy things. All right, come on, let's go. All right, so now we're gonna start machining. So let's talk process a little bit. First thing I did was actually cut a few pieces of material. Material dropped off, grabbed the material, put it into the vise, slid it over, and clamped. Now the clamping is important because I'm actually clamping decently on this part, right? Not too much, but enough to lock it in. Then I'm bringing the Kennametal shell mill across, boom, boom, boom. But guess what? I'm 7 thousandths above where we're going to end up. Because after all the holes are in, I'm gonna actually release the pressure. I'm gonna come in and just hold it nice and gently. And I'm gonna come back in, you know what's gonna happen? We're gonna kiss the baby and just bring it right in so the part comes out nice and flat, all right? All right, so the next tool is a 1/2" 5 flute. It's the Core 5. I'm gonna drop down 300 inches a minute around the outside. It's just aluminum. We're only making a few parts, so we're just gonna jam around the outside. Then we're gonna come back with a 5 thousandths finish pass and just kiss that baby. Boom. Then we're coming in with a Go drill, 100 inches a minute, 11,000 RPMs. Boom, 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 boom. That's a lot of booms, right? And we're just going right through the process. There's like 180 holes, but we're going 100 inches a minute, so it's actually going pretty quick. I'm gonna come in with an 1/8" end mill, and we're gonna drop down, and we're gonna interpolate our dowel pin holes. Now that the holes are drilled, now I'm gonna come back with the chamfer, all right? Because the drill is self-centered. So I actually drilled everything. Now I'm actually gonna drop in, boom. I'm gonna do a tiny dwell and I'm gonna chamfer all the different holes. and then deburr around the outside just to make it super clean. So now that the drilling's done, the end milling is done, and the chamfers are in place, now we're gonna come back with a 1032 roll tap, and we're just gonna tap all the way across, boom, boom, boom. All right, so now that the tapping is done, let's actually open up the vise. Let's close it. But now we're just gonna go so gently. Boom, just very little pressure. We don't want that center actually lifting from the pressure. And now I'm gonna bring back tool 1, which is the Kennametal face mill. But instead of 11,000 RPMs, we're gonna run at 4,000. All right, because I don't have a lot of pressure on here. I just wanna come in and kiss it and make it beautiful. Boom, this thing is coming out insane. I can't wait for my kids to see it. So now let's open the vise, let's blow it off, let's flip the part over, and we're gonna repeat a couple of the tools. First, we're gonna go with the face mill. We're gonna deck off the hat, boom, 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 all the way down. Then we're gonna come back with the chamfer and just chamfer all the holes across the part, chamfer the outside edges, make it absolutely beautiful, and then mission accomplished. We're done. Boom! Check that out, check that out. Oh man, looks so beautiful. I just took it into inspection, put an indicator on it, mic'd it, double checked everything. It's within 2,000s. And for this part, for that table in that machine, that is good enough, all right? So you guys can see 1032 threads going all the way through. And then you got these dowel pin holes right here. Oh, it looks so good, right? So I'm actually gonna go put it on the table over here by our MyStar CMM. I'm gonna put it on the table, and I'm gonna show you how it actually works, all right? Check this out. So as you actually turn this guy, it has a cam inside and it moves. So you'll see as I go down, it moves in and it moves out. See that? Moves in and it moves out. So for now, we're gonna actually have it just kind of move in to its stroke on these back ones all the way forward. Then take another one. I'll put it right here. Don't want to bottom it out. You want to back off right there. So these ones, I'm gonna back off this way. So back out, take this guy, put it through here, boom. You can put more here, you can put more here. Boom. You could put another one over here if you wanted to. Boom, boom. Have 4 of them just to be safe. You can take more blocks. You can put one up here. You put one down here. Boom, 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 boom. Basically, any size part now, small or big, you can actually have on here, and you can actually run around the entire profile because it's locked nice and low down at the bottom. And you can just invent your own little fixtures that you can screw in with these threads to actually lock it down. Boom. And there you go. So check this out. 1.5, 2 inches. When you actually look at the packaging for the Miteebite, this is the MB3 clamp, which is a 1032, and on the packaging it tells you that from the center of the clamp to the edge is 250 for this clamp, okay? And that's why we actually spaced them the way we did. So this piece of material is 1.5, therefore it's 250 off, 250 off, 250 off, 250 off, perfect. This is a 1, 2, 3 block, so that is 2 inches, therefore 250 off, boom, perfect spacing. I just want to tell everybody, like, you got to be serious about manufacturing. When you actually build a fixture like this, you got to make sure that you understand what size your material is, and then it doesn't fluctuate. Because if the material fluctuates, is too small, then you might clamp it and think you have it clamped well, and then it flies out, causing bodily damage, or at the very least, screwing up your part, right? So we got to make sure that your math is correct. Boom, but that's how it works. You got the stop right here, you got the clamps, boom. I could put something small over here, whatever you want. You could just figure it all out. Right now I'm just using the clamps themselves, but Miteebite has like little rails and different things. Our whole pattern probably doesn't work for that, but for me, this works fine. There's very little pressure on the machine. We're using tiny little end mills. Boom. You can see like, oh, it works. You know what I mean? So there's no way this is gonna come out with those tiny little end mills. Anyway, oh, check it out. Like it works, right? It works. So that's awesome. I gotta get back to my family. I'm gonna take this guy, I'm gonna go install it. We're gonna do some machining. We're gonna put up more videos. If you have not subscribed to MakerSpace 77, our YouTube channel dedicated to raising up an army of makers, go ahead and hit that subscribe button, tell everybody about it, and just share it, because that's what we need. We need to lift up manufacturing. We need to get our kids involved, and we need to get them solving problems, making cool things, which gives them confidence and makes our society, our states, our countries strong, because we care about manufacturing, all right? You guys have a blessed day. I'm out. Boom.